Hi, today I'm going to talk about how to generate a simple sine or cosine wave data if we need to generate a wave data set for any reason. I'll show you how to do that. First, I'm going to show you the MATLAB syntax, and then I will show you how to do it in Python. So if we want to generate any wave data, the very first thing that we need to set is the sampling frequency. And basically the sampling frequency tells us how many data points we are going to generate in 1 second of data set. So if here I set it for 100, it means that every 1 second of my data set is going to have 100 data points. So you can work with that and make it less or more depending on what you need. The other factor we need to define is the duration of the data set we have. For example, for how long we want to generate that data set. Here I set it for 60 by 60, just 1 hour, so just make it in the second. So it's 3600 seconds. So whatever seconds you need, so make sure that you have the duration in seconds, and whatever seconds you need, the 1 hour, 20 minutes, 2 hours, 15 minutes, whatever. So, and put that number as a second here as a duration. Then here we define the delta t. The delta t shows the time interval between every two sample points that we generate. And basically it's just 1 divided by the sampling frequency we defined here. So if we have hundreds data points, if we have 100 data points in 1 second, then obviously the time between every two data points is going to be 1/100th of the seconds. When we have the delta t, we can generate the time vector, the time vector of the that represent every points we are generated in the data set. And I start from 0, so I assume I want my data sets start from 0 and keep increasing delta t to with the interval delta t until I get to the total duration minus delta t. And the reason I have minus delta t is because I start from 0. If I start from delta t, then it's going to be the duration. One other way you can do that is that you, instead of writing like that, you can write it as you generate an array of integer from 0 to the number of sample points you have. For example, if you want to generate 1000 data points, so you start the integer array from 0, 1, 2, 3 up to 999, and then times that array by delta t is going to give you the very same results. And then here we are generating the wave here. I here generate a sine wave. You can generate a cosine wave or any other form of the wave you need. So I simply define some of the wave properties. So one of them is the amplitude. I just assume it's going to be 0.5 meter. And then the frequency of the wave frequency. One thing that you will have to make sure you are not going to get confused between wave frequency and sampling frequency here. The wave frequency here shows that how many full cycle our waves complete in 1 second. So when I said that I want to have a wave frequency of 4 Hertz, it means that our waves has 4 full cycles or 4 full oscillation in 1 second. When I said the fs is equal to 100, it means that I want to generate my data set with 100 data point in every second. So don't get confused between these two. So this sampling frequency here represent how many data points we are generating. This one is just present the physical properties of the wave we are gonna generate. And then we can calculate the angular frequency as 2 pi times the frequency of the wave, and then the wave just is amplitude times sine. Here I put the W, but basically it's omega. So the WT plus the phase if you want to, to add the phase to that. So I didn't add the phase to that. You can add any phase to that if you want. And I plot that data here. So this is the syntax for the MATLAB version. It's very similar if you want to do it in the Python. So I'll show you how to do it in the Python. So first we import the NumPy library and Matplotlib library, because that we use the NumPy library to calculate the arrays and the Matplotlib library for plotting. And again, the same, we define the sampling frequency, then define the duration, then the time interval. Here I use the arrange to get from 0 to duration by time step delta t, and you know that in Python the difference between MATLAB and Python is that the Python doesn't the duration is not included in the data set, so that's why I don't have that minus delta t here, because by default Python doesn't include it in the data set. If you get a problem with arrange, because the arrange function is not, it's basically good for making the integers, not the floats. So again, as I said, another way is that you can create the array of integer between 0 to the number of sampling points minus 1. So again, if we want to generate 1000 data points, we generate an integer array from 0 to 999 and then times that array by delta t. It gives us the very same results. And then here define the amplitude frequency and the angular frequency and the way and the wave, and I'm just going to make it similar to, so it's going to be, again, here I have cosine wave, you can have a sine wave as well if you need, and then I will plot it using the Matplotlib library. So I'm going to show you the result first. First I will use the Octave instead of MATLAB. Is just open source, similar to MATLAB, has some of the functionality of MATLAB, but it's the alternative to MATLAB. It doesn't have all the MATLAB functions, but it has most of the ones that we need. If in case you don't have access to MATLAB, you can go to that Octave website and download it for and use it. And most of the time you can use it. If you have access to MATLAB, just use the MATLAB. So here, if I run this in Octave or in MATLAB, so this is gonna work, and I plot here to show you. Here I plot only 100 data points, the first 100 data points basically, and because my sampling frequency is 100, it means the 1 second of data, because I have sampling frequency equal to 100, means that every second of my time wave generation has 100 data points. So I plot that 100 data points, which means that 1 second of data. Simply make it larger, so you can see this is 1 second of data, and the second wave start from this point, so we don't see it. So let's go there. If you can see that these data point, this circle point, shows this the sampling data points that we have. So if we keep count them, so it's a 1, 2, 3, 4, 5, eventually these are going to be hundreds of, it's going to be 100, because we have 1 second, sampling frequency is 100, so we have 100, we generate 100 data points in every 1 second of data. And if you look at the oscillation of the wave itself, you see we have one full wave up to here, then the second full wave up to here, then the third full wave up to here, and then the fourth full wave up to here. And it's because we have this wave frequency equal to 4. So because we have it, the wave frequency is 4, we have 4 full oscillation in 1 second of data. And because we set the sampling frequency equal to 100, we have 100 data points in 1 second of data. It's very same if we use the Python to do that. Here I use the Anaconda and the Spider on Anaconda to run it, but any other Python distribution or Python itself does the same thing. So you can run that, and then it will gives you it will plot the 100 data points here, and you can see what's happening. And just to make it similar, so here I plot the cosine wave. If I plot the sine wave instead of the cosine wave, it's going to be similar to the other one that we have. So that you can see it's going to be exactly the 4 full oscillation with 100 data points with 1 second of data.